Hello, my name is George Conrad. I'm President and CEO of Power Verde Incorporated, a renewable energy company that me and my partner, a Boeing engineer, Fred Barker, started out a couple years ago with the help of my machining company, Arizona Research and Development. We were able to produce a motor that we planned on implementing on the natural gas pipeline or CO2 pipelines, using that Mother Nature's pressure to generate power in remote areas. What we've come up with is a patented design rotary a radial piston motor, totally sealed, that can handle up to 500 psi, and we decided to we're utilizing multiple different types of fluid depending on the climate. Each refrigerant or chemical that we use is based upon the heat source of that general region. So we're going through a lot of testing. We're testing with freons right now. We could be testing with propane, with ammonia. These chemicals can be used outside the United States due to the EPA restrictions here. Those chemicals can create a lot more pressure for us, a lot more efficiency. So we're going through our testing, and we hope to be able to utilize a lot of those different freons. In the back of our building, what you'll see is our system. It's a test module that we are pulling the waste heat off of a 150 kilowatt diesel genset. This is a test module that we can go to foundries. We can extract the data from this diesel genset, so we can explain to each foundry or each heat source of every different type of industry that how much power that we can generate for them. It's all about the BTUs that we can pull and capture from any system or application, and there's a lot of applications. There's foundries, there's heat treat companies, there's powder coaters that use ovens. All these waste heat facilities is an excellent way for us to capture that heat and give them energy back, get their energy back into their pocket. Depending on the systems, we will be using either a glycol or water. What we're doing is we're circulating hot water or the working fluid through their heat source. That heat source is expanding our refrigerant or the freon or pentane, whatever fluid we decide to use for that application. We are then transferring that heat into energy, and that energy, what we've developed, our motor takes that energy and turns it into rotary power, and that rotary power then turns a generator, and they can recoup some of their energy back. The amount of BTUs that is transferred through the transfer of heat expansion from hot water to the refrigerant using flat plate exchangers, using tube collectors, any type of transfer of heat units that you can purchase directly off the shelf, we can transfer and put that energy back to use. I'll kind of explain a little bit of the process that our system is using. What we're doing is we're circulating water through a specially designed exhaust heat exchanger that has been designed for this Cummins 150 kilowatt diesel genset. Each application will have its own particular way of extracting the heat. We take that heat and we're running that heat through a evaporator. That evaporator also has the refrigerant running through it. We have a high pressure pump that takes liquid refrigerant and injects the liquid refrigerant into the heat exchanger. At that point, that's where we generate all of our power. That heat, when it hits the refrigerant in a liquid state, turns it to vapor. That vapor creates a tremendous amount of pressure and volume. That is what creates the rotation power of our motor. That back pressure, that pressure pushes our pistons down in perfect harmony. We have a patented design of rotary valving that is absolutely unique design that keeps the motor simple. Special design of our motor, the way that the valving and everything works, the pressure pushes the piston down and on the way out, that through the rotation of the high pressure on our piston, it rotates the crank, which in turn is hooked directly to a generator, and that's what creates our power. The secret to our motor also is the more back pressure we have on this motor, the cooler the refrigerant or the gas coming out. It's like an expansion. It's a decompressor. That refrigerant drops 50 to 60 degrees. The more back pressure, the more it plays into not having to spend any energy to recool the refrigerant. That refrigerant is coming out cold. We have very little condensing action that needs to be done. So the design of this, the more back pressure we have, the less cooling we need to create the loop system. And there's two loops. Actually 3 loops to our system. There's a cooling side, a heat side, and the refrigerant pump side. So with all these 3 systems working together, that is how we're generating the power and the system that you're seeing today. Generating about 12 kilowatts of power with the system that you see today. We're only capturing 50% of the heat off of the 150 kW diesel genset. The system creating more power. It's all about the heat. It's all about the expansion of the refrigerant. The more heat we have, the more power we can deliver on the other end. The cost of the system that we're going to implement with Cummins is approximately $20,000. That is specially designed components from Cummins to help generate this, to make sure that we don't affect the diesel genset's running capability.